welcome to NASA Edge.
An inside and outside look at all things NASA.
And today, those all things are LRO and LCROSS.
And what's LRO and LCROSS stand for?
I'm glad you asked, Chris. LRO, Lunar Reconnaissance Orbiter, and LCROSS, the Lunar Crater Observation and Sensing Satellite.
And I think what we'll do is we'll start out with LRO for the first half of this podcast, and we'll get to LCROSS later.
Because LRO is actually the first step in our returning to the moon.
Absolutely. In
Very
fact,
important part.
the LRO mission, which is unmanned, will be creating a comprehensive atlas of the lunar surface because it's going to aid in the design of a lunar outpost.
So what are the features, Chris, the options, if you will, on LRO?
With the apps?
Yeah, the apps.
At the apps on board?
Proverbial app store.
The first one is going to be the Cosmic Ray Telescope for the effects of radiation. That will characterize the lunar radiation environment, allowing scientists to determine potential biological impacts. The Diviner Lunar Radiometer Experiment, which will measure the surface and subsurface temperatures from orbit. The Lyman Alpha Mapping Project will map the entire lunar surface in the far ultraviolet spectrum. The Lunar Exploration Neutron Detector will create high-resolution maps of hydrogen distribution and gather information about the neutron component of the lunar radiation environment. The Lunar Orbiter Laser Altimeter, or LOLA, will measure landing site slopes, lunar surface roughness, and generate a high-resolution three-dimensional map of the moon. The Lunar Reconnaissance Orbiter camera consists of two narrow-angle cameras that will make high-resolution black and white images of the surface, and a third wide-angle camera will take color and ultraviolet images over the complete lunar surface. And finally, the Mini RF Technology Demonstrator, which is going to be an advanced synthetic aperture radar that operates in both the X and S bands of the radio spectrum. So a lot of data is being collected from all these instruments.
That thing was packed like a sausage skin.
Lunarly speaking, I guess.
That's right.
Interestingly enough, we did. When we went through the clean room, or just after that, we got to talk to three gurus that actually work on the project. Why don't we take a look at what they had to say, because it'll make a lot more sense than what we're trying to do now.
Exactly.
So let's check it out.
Check it out. Yeah.
Hi, we're here with John Keller at NASA's Goddard Space Flight Center, and we're going to talk about an exciting aspect of LRO, which is, I thought was a reference to a Kinks song, but is really something much greater, LOLA. What is LOLA?
LOLA is the Lunar Orbiter Laser Altimeter. It's one of the 6 instruments on the spacecraft. And what it does is it measures essentially the shape of the moon.
Okay, how does it do that? That sounds like a complicated task for someone like myself.
The spacecraft, of course, is orbiting the moon constantly in a polar orbit. As the moon rotates underneath, the instrument is firing a laser constantly down at the surface of the moon.
And kind of like a laser-driven sonar, almost.
That's right.
Okay.
It's called an altimeter, and we know the speed of light, and therefore we know the distance.
Hey, I'm at NASA Goddard Space Flight Center with Noah Petro, who's a planetary scientist, or Goddard's Expert Lunar Guru, or ELG.
That's right.
And behind us is the LRO spacecraft, which is actually going to be the first spacecraft heading back to the moon sometime this year. And what's going on in the clean room?
Well, they're just doing an alignment test of the spacecraft. The spacecraft in the past few days has been through vibration testing, where they shake the spacecraft very violently.
Right.
Now they're making sure that everything has stayed properly aligned.
Cool. Now, this is a very exciting mission for us, as you know, because we're going back to the moon, and this is the first spacecraft going back. And there's a lot of scientific instruments on board. And as a planetary scientist, how important is this spacecraft?
Well, this spacecraft is going to return some of the best data we've ever gotten from the moon, and it's going to return data from the entire surface of the moon. Instead of looking in high detail at one or two specific locations or various landing sites, we're going to be looking at the entire surface of the moon. So for the first time, we'll get a lunar-wide picture of the moon in very, very high detail. Data representing topography, composition, so it's very, very exciting.
So essentially what you're telling me is that we'll finally be able to map quests on the moon.
Absolutely. We'll be able to map quests down to the centimeter level with some of the instruments aboard the spacecraft.
Hey guys, I'm here with Tim McClanahan, who is a participating scientist with the LIN instrument on the Lunar Reconnaissance Orbiter. LIN stands for Lunar Exploration Neutron Detector?
Yep, exactly.
Well, what does it mean?
Well, what we're actually trying to do is we're using a detector to look down at the surface of the moon and try to detect hydrogen. And so we're interested in trying to figure out how much is there, because hydrogen might be an important element to be able to use for future exploration uses of water and possibly use it for rocket fuel.
You're also looking for any signs of surface water?
Yeah.
There's another instrument on the LRO that also is looking for subsurface water. That's the Mini RF technology.
All right.
Is there a little bit of overlap there?
There is certainly intersection because many times the instruments look at things from slightly different perspectives. And what LEND is going to try to do is detect the emission of neutrons. And by looking at the different ways that the surface of the moon emits neutrons and the energies that we get, we can then make the case for how much water might be in that particular position on the moon.
The way their instrument works, it has one laser, but it splits that laser into 5 spots. And those 5 spots hit the surface of the moon at about 25 meters apart. And that gives them instantaneous slope information as well. That slope information will help us find those areas that are acceptable for landing. And we're looking for areas with potential resources. We're looking for an area that has what we call points of permanent illumination.
Oh yeah, daylight.
Daylight all the time. Essentially, that's right. Because this moon is only tilted a little bit, even as the moon rotates, some of the higher elevation areas may be in view of the sun at all times. But we expect that real estate to be fairly small. We're trying to find within a relatively small area what are the safe spots there. And so,
gotcha. And then another thing this does is gives you more options for that. I mean, if it's a relatively small space, you can at least define that and say that's the window where we want to go. We got permanent illumination. We can throw up our solar panels and be in good shape.
That's right.
All the time.
And what we'd like to have is to find a source for water that we can have there because it costs tens of thousands of dollars per pound that we take up into space. And if you had to take all that water with you, well, that gets to be a really expensive proposition. So what we'd like to be able to do is find as much in line of resources as we can on the surface of the moon so that we don't have to fly it up there.
I'm most interested in the composition of the lunar surface and how the composition can vary over distances. So, I think we think of the moon as being very simple. And what we're starting to realize is that the moon is very complex, and the geology and the surface of the moon can vary over very small distances. Right. And what this spacecraft will allow us to see is how that change in composition over small distances can influence where we might want to return with a landed spacecraft, or we may want to send future missions. Well, my particular favorite place on the moon is a large feature called the South Pole Lake and Basin. Oh, okay. It's the largest crater on the moon. It's about 2,500 kilometers in diameter, about 10 kilometers deep. It's thought to be one of the oldest impact crater on the moon, and there are rocks at the bottom of that crater that have never been sampled before.
Wow.
We don't know how old the basin is, so there are many interesting unanswered questions, and it's a fascinating place that we've only just started to really understand what's going on there.
Now, is there a potential for water ice in that basin, you think? Or?
Well, the part of that basin, because it's so large, it goes from just near the equator to the south pole of the moon. So you can still be inside the basin and be standing at the south pole of the moon, and the south pole is where there's the possibility for having water ice at the surface. So that's one of these areas that this spacecraft will be looking at. LRO is going to, as I said before, is going to be such an exciting mission because it's going to return so much data, but it's only one of 4 spacecraft that will be orbiting the moon.
Oh, that's
There's
cool.
a Japanese spacecraft, a Chinese spacecraft, an Indian spacecraft. We are going to get a complete and very detailed image of what the moon is made of, what the shape of the moon is. We're going to understand the moon in ways that we've never imagined to be possible.
And the great thing about all this data is that this data will be available to the public.
Absolutely. With the LRO data and data from some of the other missions,
right,
they'll be made available to the public. I know that certain images that'll be returned by the spacecraft will be made available the day that they're taken.
Right.
Eventually, within a year of the mission, all the data will be available, so anybody can go and look at the images, look at the data, and do their own analysis.
I'm like glad Lola's part of the team here. That'll be great.
it will be.
Awesome.
Hey, so what do you think?
I'm still amazed at just how much is actually on the satellite. We only had them talk about a few of them. So
Right.
It's just, I'm kind of overwhelmed actually. But also seeing the satellite there in the White Room, being wrapped up and ready to be shipped down to Kennedy, it was amazing.
Yeah, it's not every day that you get that kind of access, so it was really good to be there.
We'll be right back. We'll talk about LCROSS, and you're watching NASA Edge.
Hey, an inside and outside look at all things
NASA, let me tell you. Welcome back to NASA Edge.
An inside and outside look at all things NASA.
Hey, before we get to LCROSS, we want to introduce a special guest, and I forgot to introduce him at the beginning of the podcast.
Sure.
We have Spooner, who is the official mascot for the Exploration Technology Development Program.
Yeah, and there's actually a little inter-office bet. Who will know more about LRO and LCROSS after the show, myself or Spooner?
You want to take a dibs on who knows more, Franklin?
I'm gonna give it to Blair.
The Blair? Okay.
Nice. The odds are on the chimp.
Hey, so who do we have on the phone now?
Well, we're going to talk with Jennifer Heldmann.
Okay.
She is our LCROSS expert. Thanks for coming on the show.
Oh, thanks. My pleasure.
Well, we talked about what LCROSS is, but what exactly does it do?
LCROSS is a very cool mission. So we're actually going to impact in the north or south pole of the moon. And when you make a big impact, you kick up a lot of dust and dirt and debris, maybe water ice if it's there. That's our real reason for going. We're trying to see if there's water ice on the moon. So we have this impactor, and then right behind it, we have a shepherding spacecraft that follows and flies right through that plume and makes a bunch of measurements, sends them back to Earth, and we're going to use that data to try and determine if there's water ice up there on our moon.
Now, you said it was the North or South Pole. So has that decision been made yet?
Right, yeah, we're looking at candidate craters and regions in both the North and the South, and we're using all of the data from all of the international lunar missions that are out there to try and pick the best spot to impact. And the key is impacting in one of these places, these permanently shadowed regions, which literally have not seen the sunlight in billions of years. So therefore, it's very, very cold and a very good place to trap water ice. And there's permanently shadowed regions at both the North and the South Pole. So we'll be going to one of those areas, and that's where we'll be impacting.
What exactly is going to impact the moon?
We are actually taking the upper stage of the launch vehicle and driving that to the moon with the shepherding spacecraft. And then several hours before impact, the upper stage of the launch vehicle, the Centaur, and the shepherding spacecraft will separate. And then it's that Centaur, which essentially is a big empty metal can at this point, is what actually literally impacts the moon at 2.5 kilometers per second. So you've got a big hunk of metal that's slamming into the moon, and when you do that, you're going to kick up all the dust and debris, and that's what we're going to be measuring.
Wow.
Are we going to be doing any damage to the lunar surface as that Centaur upper stage impacts the lunar surface?
There are impacts of this amount of energy that happen on the moon several times every month. And so when we impact, we'll create a new crater, but not a very big one compared to the size of the moon. So probably on the order of a third of a football field wide and about 16 feet deep. So that's not so large on the scale of lunar craters.
So you won't be able to see that on the telescope?
We think that if you have, a moderate-sized amateur telescope, 10 to 12-inch telescope or so, then you should be able to see some of the impact.
Cool.
Wow, that's
So that'll
great.
be really great. So it's a good opportunity for people to go out in their backyards and do some observing.
How high off of the surface is this impact supposed to throw the debris, and then how far trailing behind the impactor will the spaceship fly through the debris?
Yeah, so most of the debris will be within 10 kilometers of the surface. So compared to the size of the moon, that's not too high. And the shepherding spacecraft that's following behind is only 4 minutes behind that first impactor. So we talk about this a lot on the project, that there's 4 minutes to collect all of this data. So it's a really important 4 minutes. And it's a lot of work for 4 minutes worth of data, but we're going to learn a lot.
Now, I know that NASA is looking at the potential of Shackleton Rim Crater as a potential place for a lunar outpost. Will that impact affect that crater, or is that going to be far away from that region?
Well, we haven't located the final impact location yet because, like I said, we're taking in all of the data from international missions and from NASA missions. And then when LRO gets there, too, we'll have several months of LRO data to further refine the impact point. So there are candidate craters, but the exact location hasn't been decided yet.
Well, it's kind of like, landscaping. If it's nearby Shackleton, you might say we've got this really nice aesthetic LCROSS crater that's near our driveway or something. I mean, it could be a little like
Is
that.
LCROSS going to go ahead and map this pre and post impact?
Actually, LRO will. Yep, LRO will take data before and then also after. So you'll get some, before and after shots, and also some of the other international missions that are there too. And we'll be comparing what happens, what we observe from the LCROSS impacts with previous data, with hydrogen maps and where the permanent shadow is, and try and combine as many data sets as we possibly can. And we also have professional and amateur astronomers right here on Earth that will be collecting observations too. So all of that will be folded in, and the science team is going to be looking at all of that data to try and learn as much as we possibly can from this experiment.
You mentioned the international data that's being gathered. Are you then going to take that data that we get from LCROSS and then share that with international partners as well?
Absolutely. Yep, it's a two-way street, and so we're already working with international scientists as well. and looking at their data sets, and they're going to be able to look at our data sets, and it's all just part of putting it under this big umbrella of broadening our scientific knowledge and learning as much as we can.
I can't wait.
Yeah, I'm looking forward to it. It's going to be cool to see it impact the surface.
We're gonna have to get a little amateur telescope, put it up on top of the studio, and see if we can watch it happen.
That's right.
Live.
Yeah, it's going to be really awesome.
Well, Jennifer, I want to thank you very much for taking the time out of your busy day to help us out and learn a little bit more about LCROSS.
My pleasure. Thanks for the opportunity.
All right, we'll talk to you soon.
Okay, thanks.
Thank you.
Perfect. Do you hear what she said? She said 4 minutes of data. I mean, it's a very small window. That's one of the most important 4 minutes that we're going to see in a long time. I mean, that's pretty impressive.
Dust is going to be lingering in the air for a while.
Yeah, that's right. And to fly a spacecraft into that's
But the question, what I want to know is, will the spacecraft that's flying into it will have to wear like a mask just to protect itself from all that? Yeah.
Little oxygen sensor.
Yeah.
Man, they better have a mad air filter in that job.
You're not one of those second-tier jobs at HQ either. It's got to be the allergen filter, All right, well, great.
You're watching NASA Edge.
An inside-outside look at all things NASA and LCROSS.
Yeah.
Which is very interesting.
That's true.
Very good. Good job, Franklin.
Hey, welcome back to NASA Edge.
I'm sitting here thinking about this LRO LCROSS brilliance, right?
What about it?
I've got a question.
Cool
for
mission.
you. Yeah, very cool mission, but roll with me on this just
Okay.
real quickly. I'm a brilliant scientist, and I've got LRO, and I've developed LRO and LCROSS. Franklin, help me out if you can.
Mm-hmm.
I've developed this.
You're dreaming.
Yeah.
Okay,
Well,
all right.
it's a hypothetical.
Oh, hypothetical. Gotcha.
Hypothetical.
All right.
I'm sitting here with the plans, and I'm going, man, this is brilliant.
Mm-hmm.
How am I going to get this to space? Who determines how it gets to space?
The magic 8-ball.
The NASA 8-ball.
Well, in fact, what they do is, of course, you have the mission program, the mission office. They get together, they figure out what the mass requirements are for their spacecraft, for the size, the dimensions, and then they pick the appropriate launch vehicle.
So like in this case, the Atlas V.
Atlas
right?
V, correct.
Okay, now I've picked the vehicle. Well,
Right.
Where do I get one?
The Atlas V Superstore located down there.
Well, maybe what we should do is let's call our folks at the Launch Services Program down at Kennedy and talk to Tiffany.
All right, let's do that.
Hey, Ron, could you get a hold of her?
All right. But guys, follow my lead on this because I'm
Okay.
not going to say
I won't
anything.
say a word.
Okay.
Okay.
All right.
Flight Project Office, this is Tiffany.
Yes, hi. I have some plans here that are as brilliant as LRO and LCROSS, and I'm wondering how do I get them into space?
Is this Blair from NASA Edge?
She,
All right, no, it's a really smart engineer with some great plans.
Oh, well, then I know this is Blair.
Good call. Hey, Tiffany.
Hey, Blair, how you doing?
Doing fine. Well,
Good.
I'm wondering. I got an LSP question for you.
Okay.
I'm wondering if, in the case of like LRO and LCROSS, how do I get that into space from a launch services program perspective?
Let's just take LRO and LCROSS, for example. So right now, they're going through spacecraft processing.
Okay.
They're doing a spin balance. They're kind of going through simulations of what would happen with the spacecraft in the launch vehicle, the Atlas V.
Right.
So they're preparing and doing that and going through all those tests, charging battery, fueling, defueling, just getting ready. And then on the other side of the spectrum, you've got the launch vehicle. Now, mind you, Launch Services Program is working with both entities, the spacecraft side and the launch vehicle side.
wow.
So you're like the deal broker. I mean,
We are.
You're,
We're kind of,
it's a big responsibility.
It is a huge responsibility. We are a consultant. We start off as a consultant, and that could be 10 to 3 years.
Wow.
We're working with you guys from the very beginning.
What I want to know is what do I have to do to get to push the launch button?
Well, Blair, you don't get to push the launch button.
Is there like a one-size-fits-all rocket down there for getting, spacecraft
There
into
is
space?
that. We've got a medium class, which is a Delta II, and you've got the Atlas V, which is a heavy, and the Pegasus, which is a small.
What's happening is, I know we're talking about LCROSS and LRO, but Blair really wants to get up into space, and he's looking for a launch vehicle that will get him up to the moon.
Minimal supplies.
I'm figuring Pegasus is probably good for him, huh?
For Blair, sure, why not?
Okay.
Hey, I don't take a lot. I pack light. So, and I've lost some weight recently.
No, are all these ground-based launch systems for all these rockets, Tiffany?
The Pegasus Pegasus is not. It's dropped from an L-1011 airplane.
Oh man, good ear, Franklin.
Hey, get that parachute with you just in case. Yeah.
Just in case I have to bail out. Hey, well, thanks a lot, Tiffany. I appreciate it, and I'll be talking to you in the future about coordinating the Pegasus rocket for myself.
I look forward to it, Blair. Take care, guys.
All right, Tiffany, have a good one.
Thanks a lot.
Bye.
Wow, launch services program. They're answering all the questions.
Answering the questions. What about the L-1011, the Pegasus rocket from Franklin?
Excellent reference.
I try to do what I can.
Where'd you get the 411 on that one?
www.nasa.gov. Works every time.
Right.
It's like a champ. You know? It's right on the money.
Actually, some of the Mission Madness missions actually were launched with the Pegasus rockets. The X-43 program from NASA was launched from the B-52. So it's just an alternative to the ground-based launch systems.
So that's an excellent point. Now, my question is, can this Pegasus be modified for manned flight?
Well, it's not a
maybe for a co-host.
Yeah,
it's kind of small. I mean,
Yeah.
just got to put a cot in there.
Now on a more serious note, one thing I'm wondering about launch services, I did not hear mention of the shuttle.
It's separate. You know, what Tiffany is responsible for in launch services program, she's responsible for the launch vehicles for unmanned missions, like, you know, for Atlas V, Delta IIs, the Pegasus rocket. Shuttle is a completely different group.
Okay, so I have to have a two-prong approach. I try to get on the shuttle, and if I'm alternatives, got to get.
You're not going to get on the shuttle. Go for the LSP side.
All right.
Hey, well, we're looking forward to the launch of LRO and LCROSS coming up here soon.
Yep.
And before we go, I just want to give a quick shout out to some new NASA Edge fans. So we have Michael and Robert in Sunapee, New Hampshire. They watch our show. I guess that's how you
during
pronounce
breakfast.
Yeah, Sunapee. I'm assuming. I apologize if I'm mispronouncing that. But they watch the show every morning before they go to work.
Yeah, so be sure you tie your shoes before you head to school.
That's right.
Just a little parental advice from NASA Edge.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
And eating a good breakfast is essential, as you know, to starting the day right.
Hey guys, thanks for giving me the memo that we were wearing our pajamas to the set.
City, you're okay because we have Edge all over.
But you guys look like you have pajamas on. Then that thing look like footies. I mean, that for real looks, Chris, that looks like you have footy pajamas on, dude.
Hey man, this is the casual look.
For the record, Chris has on footy pajamas, and Blair has on a onesie.
It's right.